Problem number 28. In figure, two blocks are connected over a pulley. The mass of the block A is 15 kg and the coefficient of kinetic friction between block A and the incline is 0.20. Angle theta of the incline is 30 degree. Block A slides down the incline at constant speed. What is the mass of block B? So in this question, we have to find the mass of the block B. Mass of block A is given as 15 kg and these two blocks A and B are connected by a string, and that string will be passed over a frictionless massless pulley. Here the mass of the string as well as the mass of the pulley are very small when you compare with block A as well as block B masses. That's the reason we no need to consider the mass of the string as well as the pulley. The block A is kept on the surface of the incline. By that, there will be a friction between the surface of block A as well as the incline. So they gave the value of coefficient of kinetic friction as 0.20. And this incline is kept at an angle of 30 degree. The most important thing they mention here, the block A slides down the incline at constant speed. So that means if the block A slides down on the incline with a constant speed, means B also moves with constant speed. So if any object is moved with a constant speed, the acceleration of that object will be equal to 0. So here, for finding the answer for the block B, we have to draw the free body diagram for the given figure. So before that, we have to write the given first, and then we can draw the free body diagram. So mass of block A is given as 15 kg. So I just named as MA. MA means mass of block A. And then the coefficient of kinetic friction mu k value is given as 0.20. And the incline is kept at an angle theta which is equal to 30 degree. And block A slides down the incline with constant speed. So that means the acceleration of block A and block B is considered to be 0. Why? Because if any object is moving at constant speed, the acceleration of that object is equal to 0. Now what we have to do, we have to draw the free body diagram for this figure, and then only we can easily find the answer for the mass of block B. So first of all, I'm going to consider block A. To the surface of the block A, normal force will be acting perpendicular to the surface of block A. So by that, this is your normal force, right? And then the downward force will be perpendicular downward direction, which is equal to MA multiplied by G. And by that, you have two components. One is MA G cosine theta, and then this one will be the sine theta. So that means MA G multiplied by sine theta. These are all the two components of the force due to gravity. And here we connected the block A with a string. So that means the tension will be in this direction. And also we have the friction force which will be acting in the same direction. Clear? And let's come for the right side of the figure. We have the block B. So the tension will be in this direction and the force due to gravity will be in the downward direction. So that is nothing but MB, that is the mass of block B multiplied by G. So let's reframe the equation for block A for both the X as well as the Y forces. So let's consider block A, and I'm going to write the sum of the forces in Y direction. So in Y direction, we have the normal force. So that means the upward force which is equal to the downward force. So by that, what we will get, Fn which is equal to MAG multiplied by cosine theta. And here, when you come for the sum of the forces in X direction is equal to, we have to see the figure, tension and the friction force will be in this direction, and MAG sine theta will be in the opposite direction. And here, if an object has the constant speed, means we have to equate that with Newton's second law, right? So how we can write the equation? We have to write the equation T plus frictional force minus MAG sine theta, which is equal to MA multiplied by acceleration. Clear? So this is the sine plus, okay? Okay. Now we have to frame the equation for block B. We have to write the equation for block B. In block B, there is no equation for x direction, only we have the vertical forces. So for that vertical forces, you have to see the force due to gravity acting on block B will be greater than the tension. So we have to frame the equation, and that equation should be equated with Newton's second law of motion. So MBG minus tension, which is equal to the mass of the block B multiplied by acceleration. So we just name the equation. This is first equation. This is our second equation. This is our third equation. As we already know, the block A slides down at constant speed. So the acceleration will be equal to 0 for both objects. Because why? If this object slides down with constant speed, the same will be applicable for block B. So that means the acceleration for block A as well as the block B is considered to be 0. So in that situation, what will happen? The second equation, right hand side, anything multiplied by 0. That means when you substitute A value equal to 0, so this part becomes 0. Likewise, in equation 3, we will get 0 here. So by that, what you will get? We have to get the equation. So let's rewrite the equation. T plus FF minus MA G sine theta, which is equal to 0. Why? We have to substitute A equal to 0 in this. Clear? Likewise, this equation also equal to 0. So by that, the equation 3 becomes MBG minus T equal to 0. Now we are going to find the answer for mass of the block B. So what we have to do? Better we can rearrange this equation in terms of mass B, right? So therefore, we have to, if you want to frame this equation in terms of mass of the block B, then first we have to move this T to the right hand side. So by that, we will get the positive value. So MB multiplied by G, which is equal to positive T. And we have to bring this, we have to take this G to the right hand side of the denominator. So what will happen? MB, which is equal to T divided by G. And when you substitute the value of the tension, when you divide the tension value with the acceleration due to gravity, we will get the answer. So if you want to get the answer for the mass of the block B, first we have to find the tension. So for getting the tension, what I am going to do, I have to take equation. Which equation? So we can just take this equation, any one of the equations. So I'm going to take the second equation. What is our second equation? This equation, right? So after we substitute A equal to 0, this is our main equation. So I just name this equation as Roman 2, right? So the Roman letter 2 I just mentioned here. So now I'm going to use this equation for finding the answer for tension. So let's write this equation one more time. T plus frictional force minus MA G sine theta, which is equal to 0. So here, what is FF? Here, this FF is nothing but the kinetic friction, right? Because they gave the coefficient of kinetic friction. So we can rewrite this equation as T plus Fk minus MA G sine theta, which is equal to 0. As we already know, so what I'm going to do, first we can rearrange this equation in terms of tension. Therefore, tension, which is equal to this term, when it goes to the right hand side, it will take the negative value, and this term will take the positive value. So by that, what will happen? MAG sine theta minus Fk. As we know, Fk, which is equal to mu k multiplied by Fn, and we already know Fn, which is equal to MA G cosine theta. So you have to substitute this value. By that, your Fk is equal to mu k multiplied by ma g cosine theta. Now what I'm going to do, I'm going to take this fk and I'm going to substitute here. So if you substitute, what you will get, t equal to ma multiplied by g sine theta. In place of fk, I have to substitute this equation. What is the value for fk? Minus mu k ma g cosine theta. Let's we take the common term outside. So here mag is the common term, so I can take it outside. So mag, and inside the bracket we got sine theta minus mu k multiplied by cosine theta. So let's we substitute the value. Once you substitute the value, we will get the answer for t. And after we got the answer for t, I'm going to substitute the t value here. By that, we can easily find the answer for the block B mass. Clear? Okay, let's we substitute the value. In the question, they clearly give the value for the mass of the block A as 15 kilogram. So 15 kilogram multiplied by acceleration due to gravity, which is 9.8, sine of 30 degree minus, and mu k value they already gave. What's the value? Let's we go back to the question. So what's the mu k value? Mu k value is 0.20, right? So 0.20, 0.20 multiplied by cosine of 30 degree. So let's see what's the answer. 15 multiplied by 9.8 is 147. This part is 147 multiplied by a sine of 30 degree minus 0.2 multiplied by cosine of 30 degree. The answer is 0.33. So after I calculate this value, I got 0.33. So now I have to multiply 0.33 multiplied by 147. I got the answer as 48.51. So the tension value here is 48.51 Newton. Now what I'm going to do, I'm going to take the value of tension, then I'm going to apply this in this equation. By that, we can easily find the mass of block B. So what's that equation? Mass of block B, which is equal to tension divided by G value. So anyhow, we can just see one more time. Yes, right. So now I have to take the value of T, and then I'm going to substitute here. So therefore, mass of block B, which is equal to 48.51 divided by 9.8. I got the answer as 4.95. So mass of block B, which is equal to 4.95, and the unit is kilogram. So this is the answer for this question. That's it. Thank you.